All right, we got that far. Now that we have the hypothesis figured out, we're going to calculate whether, once we get the sample data, we're going to calculate whether we can reject the null or not. Is this sample data significant enough to allow us to reject the null? So let's get to our first one. So here's just what a null hypothesis is, blah, blah, blah. Here's, it says the null hypothesis has to contain the equal, the less than equal, the greater than equal. It's the only three things that can be in the null. You have to have the equal and the null. We either may or may not be able to reject the null. The words are always about the null. Can you reject it or not reject it? Don't accidentally say, oh, I accept the alternative. It's all about the null. Can you reject or not reject the null are the words of the answers. All right? Blah, 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 blah. You guys all read this before you got here. Just checking. Significant levels, most typical ones for significance. And don't get fooled. You're not always given the significance. Sometimes you're given the confidence, but you know how to turn the confidence into a significance. Matter of fact, let's do the opposite. The typical values for significance are 1%. What's the confidence? 99. The typical significance is 5%. What's the confidence? 95. The typical significance is 10%. What's the confidence? 99. You got it. So if you see a 90, you know it's a 10. If you see a 95, you know it's a 5. These interchange, so some problems will be given confidence, some significance. Don't let it fool you. You got to use significance when it comes to the p-value, which is this week's homework all about p-value. So you know you got to use significance to compare with. Now, let's get to it. Blah, 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 blah. We're not doing type 1, type 2 errors this week. We'll talk about them, but not this week. Blah, 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 blah. Okay, here's 2 of the formulas out of the 3. When the population standard deviation is known, that's that first one. This is all about this week's homework. This is the main one this week right here. This is the one we're doing. This is it right here. The other one that has to do with the mean is when you don't know the population standard deviation, but what you will be given is the sample standard deviation. So you got to look at, when we get past, this second quiz, it's all about your given problems where you have a hypothesized mean and then you're getting a sample mean, and you got to decide which one of these 3 it is. Do I have, you're going to, same as you did with confidence intervals, do I have the population standard deviation? Am I being given the sample standard deviation? Or is there no standard deviation? And then you know which formula to use. Let's talk about that first formula right there at the top. This is on slide 14, so I'm going to put this right here. This one is slide 14. And there it is in variables, what I have in words here. The sample mean minus the hypothesized mean is your numerator. You've got to do that first. And then you got to do the denominator before you divide, order of operations. Let me say it again. Do the numerator, then do the denominator, then divide. In the population standard deviation, which will be given to you, over the square root of the sample size. Now divide that into the numerator. By the way, this numerator determines whether this z or t, if we're doing this next week's, is a positive or negative, which then determines which one of these we use. If it's positive, you got to put that 1 minus in front. If it's negative, you don't put the 1 minus in front. See the difference? All right, and that's all based on this little subtraction right here. If this numerator ends up being negative or positive. All right. I want to get to an example here. Here we go. We're going to test the claim, if it's true or not, that there is an average number of TVs equal to 3. Equal to 3. Now you're the researcher and you're saying, you know what, I don't think there are an average of 3 TVs per household. So think about the null hypothesis and the alternative. The claim is that there's an average of 3. The researcher is saying, I don't think there is an average of 3. I think it's different. Nothing about it being more than 3, nothing about it being less than 3. It's just 3. That's why it's two-tailed. That's why you have the null hypothesis, mean equals 3. Alternative hypothesis, mean doesn't equal 3. Look at this, PowerPoint's using a 1 instead of an A. The book uses an A, the PowerPoint's using a 1. Just go with words. That is a two-tail. This is the only one that's two-tailed. Equal and not equal to. The other 2 are one-tail. But the words were equal to 3, not equal to 3. So there we go, we got a two-tail. Now, here's what I want to point out to you. Because it's two-tail, we have that extra step here. When we calculate this, we got to multiply it times 2, and then compare the significance. Let's keep reading. Says, specify the desired level of significance in the sample size. Okay, we went ahead and called 100 random households. And this is, let's say, does this say US? Yeah, it's in the US. So we had to get as many phone numbers as we can. Maybe a couple million phone numbers. We had to mix them up and pick out 100 of them and call and say, hey, how many TVs do you have? There's our sample. We did our sampling. And we're saying 5% significance. This means that the sample data has to be so far away. Now this time, the null is a 3. The sample data has to be so far below 3 or so far above 3 that, let's see, it's just two tails, so 5% means 2.5% here, 2.5% there. The results have to be in those little 2.5% tails for us to be able to reject the null, for us to say, no, you're wrong, there aren't 3 TVs per household. It's something different. But if our results are too close to 3, I don't know, 3.1 or 3.2 or 2.9 or 2.8 or 2.97, depends on the standard deviation and the sample size. But if it's too close to 3, we can't reject the null hypothesis. Our p-value is not going to be less than the 5%. We know right now on this problem that we're comparing to 5%, 0.05. Because it's given to us, 5%. And if our p-value is less than 5%, 4% or 3% or 4.5% or 3.5%, we're rejecting the null. No, the average number of TVs is not 3. But if our p-value is 3% or 3.5% or 4%, we can't reject the null. Randomness could have caused us to have slightly different, and we didn't prove anything. And so we have to accept, there's probably 3 TVs per household. You ready? We called up 100, asked them how many TVs, we add them all up, divided by 100, and what did we get? 2.84. There's our sample data. 2.84. So you take that sample mean, 2.84. Now this is a large sample size, so 2.84 doesn't look far away, but because our sample size is so large, it is kind of far. 2.84 minus the hypothesized mean, remember that's on the right, the hypothesized mean, 3, gives us a negative 0.16. Now we know our test statistics is going to be negative just because of that numerator. We know we're using that top p-value formula. Divided by, the standard deviation says right here, oh, I must have not read it, but up above it said that our population standard deviation was equal to 0.8. It said population standard deviation, that's why we're using this formula. We take that 0.8 divided by the square root of 100, which is 10. 10 to 0.08. 0.16 negative divided by 0.08 is negative 2. How convenient. Here we go. Equals NORM.DIST. Negative 2, comma, 0, comma, 1, comma, 1. Here we go. You ready? Equals NORM.DIST. Parentheses. Was that negative 2? Comma, 0, comma, 1, comma, 1. Parentheses. Are you ready? Our p-value is just a little over 2%. 0.02275. What, am I doing something wrong? Am I forgetting something?
No.
Oh, darn.
Multiply by 2.
There it is. There it is. That's what I was hoping he was going to say. I got to multiply by 2. This is a 2-tail. Hang on. Go ahead.
I was just wondering where you got the sample mean from, because it wasn't on the other slide.
No, it was given in the story at the top here, I think. Or where was it here? Hang on. I think it just gave it to us right here. Number 5, collect the data, compute the test statistics. Suppose the sample results were 100 sample size, 2.84 sample mean. But it will be in the story. I'm going to read one to you before you leave so you can see how it's given to you in the story, okay?
Okay, thank you.
But there it is there, 2.84. We calculate negative 2. We entered it into the top Excel equation because we had a negative test statistic. We just found the p-value. You guys just corrected me and told me I got one more step because this is a 2-tail. I got to multiply this times 2. So here we go. Equals, what cell is that? C4? C4 times 2. Here we go.
What
0.04. Go ahead, say it again.
Can I see what's in C4?
Yeah. Equals NORM.DIST -2, comma 0, comma 1, comma 1. Now we're multiplying times 2 because it was an equal, not equal to, right? And we get 0.0455. Are you ready? Look at these two sentences. Can we reject the null hypothesis? Yes or no? Wait, where are you? Are we recording? Hang on. You all spoke at once, and I couldn't hear any of you. Let's try again. Can we reject the null hypothesis?
Yes.
Yes. Why? Because 0.04, I can't see it, 55 is less than 5%. Boom. Done. You just did your homework. Oh my God, this is too easy. You want to go home?
Yeah.
Yeah. Yeah. Feel free. I don't know.